concept of quantum supremacy states that there are certain problems that can only be solved with quantum computers and not with classical computers. So by inventing a new engineering device, the quantum computer, we can attack certain problems that we can't even attack today. I want to expand this concept into crypto supremacy and also into software 2.0 supremacy using the same analogy. With the instantiation of this new technology, we actually are able to solve new types of problems. I want to think about this a little bit more deeper, and it is really very exciting. This is Not Even Wrong podcast. It's March 25th, 2021. This is Krim Delco. Since the last update, the fund is down roughly 1%. For the year, we are now down 9.5%. The market is up 4%, and we are underperforming by 13.5%. So I'm working on my upcoming interview with Silvio Micali. He's an MIT mathematician and creator of Algorand. In short, he's a crypto specialist. He's working on smart contracts. And my interview is going towards kind of how he envisions a new society with smart contracts and algorithmatized law and algorithmatized incentives and all these kinds of things. So this is the idea. And while I'm working on this interview, I had this idea of crypto supremacy. And what does that mean? Crypto supremacy, those are problems that we cannot solve with our current system, but might be able to solve with the new system. So examples would be the free rider problem, the tragedy of the commons problem, and the trolley problem. Those are problems that we cannot solve today with our existing systems. We cannot solve the free rider problem effectively, at least. I mean, we can maybe solve it, let's say, in a very highly centralized sort of police state. We might be able, if we policed everybody, maybe a little bit like what China is trying to do. The tragedy of the commons problem, again, could be solved maybe with central authority, but the costs would be terrible. I mean, you need some sort of Stalinist, fascist, communist regime to really solve that problem. And the trolley problem, I don't think we have a solution. So I'm going to discuss this with Silvio a little bit deeper. I mean, he's a Turing award winner mathematician. I'm sure that there is enough brain there to come up to interesting conclusions. But I want to use this idea and kind of continue a little bit and just see where I get. This is a new field for me, thinking about problems that we cannot solve in the current world, but maybe we could solve in the new world. And I just want to bring in another little tidbit here before I go and unpack everything. And the tidbit would be that ARK Invest just came up with their model. They had a price target of, I think, something between $1,500 and $4,000 per share for Tesla. That's not important. What's important is that their model, which they put on GitHub, shows certain scenarios which were discussed, for example, by Rob Maurer at Tesla Daily, as really unrealistic. And I thought to myself, well, listen, there's two things about Monte Carlo to be said. Number one, the model itself is based on parameters and some sort of distribution and things like that. So by definition, it will include things that are unrealistic on both sides, the positive and the negative. And this is why we're doing the Monte Carlo simulation. We were kind of trying to maybe not try Hilbert space here, but we're trying to really go out of our own sort of human constraints and try to capture as many events as possible. And that's the whole idea of Monte Carlo. So in that sense, I think it's valid that they have maybe some unrealistic assumptions in the model today. But why is this relevant for today's episode? I think that by bringing in new technology, we often get to the point where we can solve problems that we don't even know about today. We, to use Donald Rumsfeld's quote, the unknown unknown. We can't even fathom what kind of problems we will be able to solve once crypto works. And this is what I'm trying to sort of unpack here. So let's go step by step, and then hopefully we get to a bit of a more concrete conclusion here. So the quantum supremacy is a concept in quantum computing which states that there are certain problems that we can solve with quantum computers that cannot be solved in with classical computers. So this, by definition, allows for problems to be solved in quantum space that cannot be solved today. For example, RSA, crypto safety, cannot be solved today in any kind of efficient, cost-efficient way. It can be solved in quantum. And there's many other problems, and probably problems that we don't even know about. So I want to now transfer this concept to the crypto world and say, well, here's the same thing with crypto. Like we're thinking, okay, what could crypto do today? And for example, we have a store of value with Bitcoin. This is a problem that we have today, and Bitcoin is just a better way to do it than, let's say, gold or something like that. Fine. But crypto could also help us, particularly the universal crypto, which is Ethereum and Algorand and other blockchains that have smart contracts or Turing complete, allow for Turing complete scripts within the contract. Therefore, we have basically a universal ability to do anything with those contracts. And potentially, we could end up in a situation where we can solve problems that are not solvable today. For example, tragedy of the commons, free rider problem, trolley problem. So here's the question. Is it possible that with this new engineering tool, so we have decentralized consensus, can there be a way to solve the free rider problem? And the answer is, I think there is. I can't prove it. This is something I want to discuss with Silvio, but I'm just thinking the problem of the free rider problem is monitoring and transaction cost. And the only way we can solve the free rider problem today is by having some sort of Stalinist government. And this is probably why we had this terrible fascist and communist regimes, because they wanted to solve the free rider problem. The tragedy of the commons problem is a similar problem, where it's about monitoring, it's about transaction costs and monitoring. A decentralized system potentially could take care of that. I have this one example where we're trying to build, we have a village of 100 people, 100 households. It would be beneficial for that village to have a distributed solar system with a large Tesla megapack. Everybody could have enough solar energy and trade the energy amongst themselves, so the whole village all the time would have enough energy to survive without the grid. How do you build this system? You can do it in a central way, but then you have corruption, you have delays and all that stuff. Or you could do it in a decentralized way where you build a smart contract which says, I'm going to pay $10,000 to build this system. If everybody chips in, 100 times $10,000, that would be, what is that, $1 million. Therefore, that's enough for the contractor to build the system. Or let's say I do 100,000 times 100, so $10 million, and Tesla can build this perfect system. But I'm only going to be charged my $100,000, my $100,000 if everybody else pays. Only if everybody else pays, the contractor can cash in. So if one person doesn't pay, so I need unanimous consent to do it. Now, of course, in practice, this could be very difficult. So you could maybe have a margin and things like that, and not include those who don't pay and things like that. It's all fine. But my point here is that there is at least an attempt to solve this problem with the contract itself, without monitoring. You could have it embedded in the contract. This is a concept which I would call, in crypto space, we can solve the problem. In classical space, we cannot solve the problem with reasonable cost, also under the constraint of freedom and privacy and all these other things. This is important. We can solve the problem of free rider and tragedy of the commons if we give up on privacy, if we give up on freedom, etc., etc. In this case, we can solve it without giving up freedom and privacy. So this is very exciting. I think, therefore, I'm also incredibly excited about the blockchain technology as a means to organize society in a much more efficient way. Now, let's talk about Software 2.0. I spoke about this yesterday. Andrej Karpathy's concept of Software 2.0, which means that we build software in a very different way. We write, instead of writing code and then compiling it and then testing it and then rewriting it and compiling it and testing it, what we do is we build an algorithm which is kind of like the compiler. We then feed the algorithm with data. The data is kind of like the software, the algorithm is the compiler, and the output is the prediction. And then we continuously integrate, in a sense that we continuously feed data and the algorithm continuously adapts. This is a new concept, and now the question is, do we have problems in Software 2.0 that we can solve that would not have been solvable in Software 1.0? And the answer that Karpathy probably would say is yes. For example, computer vision can be solved like that. We can actually, if we have enough data and if we have enough intelligent ways to label the data, we can solve computer vision. It would be very costly and would take a long time to solve that same problem. in the classical way now, or in the software 1.0 way. Now, I want to go a little bit further and think about what other problems could be solved in such a way. For example, if I take Tesla as an example, and I think software 2.0 will become a much more integral part of Tesla, and therefore a much more also competitive advantage. For example, the insurance problem, which is, what is the insurance problem? How much premium should I charge in optimizing against the risk of failure? Well, if I manage the way people drive, I might also be able to charge them less so they make less accidents. This combination can be solved maybe in classical ways, but I think this is a software 2.0 problem that can be solved. So you could potentially pay a lot less for insurance if you drive in a specific way. And if Tesla controls that through their algorithms, then they can also control the pricing. So this is something that I see as a huge potential opportunity, and therefore I think Tesla insurance should not be underestimated. So to conclude this episode, I don't want to go much deeper because this is really a work in progress here. I just want to bring in the concept of quantum supremacy and say, look, there are problems in quantum computing that we can solve that we cannot solve with classical computing. There is crypto supremacy. There are problems in the crypto space that we can solve that we cannot solve without crypto. For example, the trolley problem, tragedy of the commons, and software 2.0. Again, there are problems we can solve that we cannot solve with software 1.0. And this is very exciting, in particular for Tesla. Thank you.